All right, now we're going to put this together with what we learned in the last unit, and we're going to use this to write our equation in slope-intercept form. It's right in the name what this equation gives us. It gives us the slope, and it gives us the y-intercept. Slope and the y-intercept, along with an x and a y coordinate that we can use to basically describe this line. So we're really going to just write this x and y as variables. And our m in front of the x is talking about the slope, and the b that's being added or subtracted onto the end of this expression, that's our y-intercept. And again, the x and the y here, they're really talking about coordinates that are on this line. So for right now, we're going to leave those as x and y, because those coordinates can change. But the slope and the y-intercept stay the same. So we're really just reading this equation. What's the slope and the y-intercept? The slope is 4. It's just the number that's being multiplied times the x. And the y-intercept is a -9. You want to make sure that you keep that sign along with the number. On the next one, the -2 is our slope. It's the number that's being multiplied times the x. And the number that gets added or subtracted is our y-intercept. That's 6 here. Third one, our slope is 1/2. And our y-intercept is a +8. On the fourth one, our slope is this -3/4, and our y-intercept is -12. Going backwards, it's just as simple. We're taking the slope and the y-intercept that they give us and writing it into the equation where it's supposed to go. So it's y equals mx plus b. Our m goes in front of the slope. Sorry, our x. The m, the slope, goes in front of the x. It's being multiplied times the x. And our y-intercept goes after the x. And we're just going to write that -3 as a -3. The last one, our slope is 1/2, and our y-intercept is a +7. So our slope is 1/2. So 1/2 x, and it's a +7. So write that as a +7. All right, so now we're going to put this together from a graph, from a table, from coordinates, and we're going to write our slope-intercept form. So remember, slope-intercept just has two pieces, the slope and the y-intercept, the m and the b. So we just need to find those two pieces. I'm going to find the easy one first. On this graph, you can clearly see our y-intercept. It's just that point. It's wherever our line, wherever this line hits the y-axis. Here, that's +7. So 7 is our b. Finding the slope, you could use the equation that we just learned about, or really just use your rise over run and count it out. You're allowed to use that y2 minus y1 over x2 minus x1, and there's sometimes when it's more practical to use that. When it's giving us a graph that we can easily count, I would just count it out, use rise over run. It's going down 1, 2, 3 spaces. That's a -3 as the rise, and then it's going over 1, 2, 3, 4. So our slope is -3/4. Oops, kind of messed that up. So our equation is y equals -3 over 4x plus our slope, and y-intercept just get plugged into that equation, and y and x are still variables. What the y and x really represent are points on this graph, 0, 7, and 4, 4 are points that make this equation true. We can plug in 4 and 4 for our x and our y, and that equation remains true. You can actually see on this line, 8, 1 would also work. We can plug in 8 for the x value and 1 for our y value, and that would still make this equation true. That's all the x and y are talking about. For right now, we're just leaving it as variables because it applies to every x and y that are along that line. Make sure that you check that this slope makes sense with that graph. This is a negative slope, so this slope should be a negative number. It's a negative slope. On the next one, it's going to be easier to use that equation. Y2 minus y1 over x2 minus x1. So I'm going to do y2 minus y1 over x2 minus x1. So I'm going to do 18 minus 10 over 6 minus 0. 18 minus 10 is 8. 6 minus 0 is 6. And I'm going to simplify that fraction to 4 over 3. I'm just dividing the top and bottom by 2. So my slope is 4/3. My y-intercept is right in that table. They're not always going to give this to you, so we're going to have to do an extra step to figure out the y-intercept sometimes. But here, they're telling us the y-intercept. 0, 10 is the y-intercept. So 10 is the number that we're going to be adding to the end of that expression. Y equals 4/3 x plus 10 is our equation. That's our slope and our y-intercept in the slope-intercept form of the equation. It says you try, but I'm actually going to do one of these with you. I'm going to do this first graph with us. So again, we just need those two parts of the graph. We need the slope and the y-intercept. That gives us our equation. I'm going to find the y-intercept first, just because that's a little bit easier visually. It's that spot. That's 0, -1. So -1 is my b. Deciding on the next point to use is a little bit tricky sometimes, but you just want to make sure that it's on these grid lines. You want to make sure that you can count to it easily. So you could use this one, you could use that, you could use this. That's actually a little bit off. That's supposed to be on that grid line though. Really, we're supposed to be using any of those 2 points. It doesn't matter which two, because the slope is the same the entire way down. You could use this and this if you really want to, but that's a lot of counting. You don't need to do that. I would use 2 points that are close together, and I would always start off with the y-intercept. I'm going to start at that point and count my rise and run. So it's going down 1, 2, 3. My rise is 3. It's really -3. It's going down 3. And my run is 1, 2. That's always a positive number because I'm counting it to the right. This can be negative or positive. It depends. Here I'm going down, so that's negative. So my slope is -3 over 2. And now I'm going to write it into that equation. Y equals -3/2 x minus 1. That's my y-intercept. That's my slope.